Start IT timer, please. When he says containerization is a type of virtualization, what does he mean?
He means that containerization isolates applications and their dependencies in separate containers on the same operating system, similar to how virtualization uses virtual machines. The key difference is that containers share the host OS kernel, making them lighter and faster to start compared to full virtual machines.
Like the thing that makes virtualization, I thought was that you're virtualizing the hardware, right? Or no?
That's right. Traditional virtualization creates virtual hardware environments so each virtual machine can run its own operating system. Containers skip that step, sharing the host OS but still isolating apps. Both approaches provide isolation, but the underlying
But you're not like virtualizing the app because the app is already virtual. So that's what's confusing to me to call that a type of virtualization. You see what I'm saying?
I get the confusion. Virtualization traditionally refers to creating virtual hardware, while containerization creates isolated environments for apps using the same underlying OS. They both provide isolation, but at different layers. Containers are considered a form of OS-level virtualization because they simulate separate user spaces instead of separate hardware.
Oh, they simulate separate user spaces. Can you explain that a little bit more?
Sure, in containers, each application runs in its own isolated environment or user space with its own file system, libraries, and settings. They all share the host OS kernel, but from the app's perspective, it feels like it's running in its own isolated world. This isolation makes it easier to run multiple apps without interfering with each other.
So it's virtualization because uh, it's virtualizing user spaces.
Exactly. Containers virtualize user spaces, meaning each
Okay, before I get into this, I need to. What is this general? I don't know what that's for. General what? Um, yeah, I need to figure out how to put this into the bigger picture. So MMC is something that exists. Driver. Yeah. Okay. Cool. MMC also manage. Does MMC also manage the print share print servers type stuff? Okay. So is there a print share, print server like settings or something? Or does MSC just manage the print share, not the print server? So how do I describe that? OCR is more about scanners, not printers. It's scanner software, not printer software.
of the toasted marshmallow flavored syrup. Then, going in our 16-ounce clear cup, we're going to do 2 pools of the chocolate cookie graham cracker pieces. Next, we're going to fill it up with shake base to the red wine. Perfect. Now we're going to add some ice cream up to that red wine there. Our dough lid on top. Give her a little shake. Make sure that spinner goes all the way down to the bottom. Get all that chocolate cookie graham cracker piece. Perfectly blended. Now we're going to vigorously shake our toasted marshmallow whipped topping. Vigorously shake it. Hold it straight up and down. And fill that dough lid with your toasted marshmallow whipped topping. We want just enough to hold that cherry. All right, we're going to grab our cherry. Make sure it's stem side up. Push it down a little bit. There you have it, our toasted marshmallow milkshake.
So MMC allows you to edit your drivers, print share, and print server. And just what general print settings? Like what else would be examples of that?
In this lesson, we're going to talk about sharing print devices. It can ultimately lower your costs associated with will reduce your administrative overhead and can such as one running on Windows or Linux, is definitely recommended to manage multiple printers more efficiently. Now, if you're working with a Windows-based print server, you're going to be using the Print Management MMC or Microsoft Management Console snap-in. This tool allows you to centralize printer management tasks, share.
Windows and Microsoft are the same, right? Windows is like something that Microsoft made.
Printers across the network, monitor your print queues, and troubleshoot issues. Centralizing printer management through a dedicated print server will reduce your administrative overhead and can ultimately lower your costs associated with supporting a large network of these printers.
Okay, so MMC is just general printer stuff. So a print server is an example of a thing that would initiate a print share, right? So does the it goes first, it goes from the driver to the, so first you need, so first you could have like a print server, or no, you would need the print server. Okay, so first, ignoring the print server, you need a computer. That computer is going to initiate a print share, so then they will, that creates that connection, that allows that connection to occur between the printer and the computer, right?
Correct.
Okay, and then they need to send a file to the printer, right? That's the next step.
Exactly.
And in order to do that, they need to have a driver, right?
Yes, the driver is essential. It translates the computer's data into a format the printer understands, so the print job can be processed correctly.
Okay, so then you need a driver, and that driver essentially what it does is it turns the file into a PDL, right?
That's right. The driver converts the file into a printer-ready language like PCL or PostScript so the printer understands it. Anything else you want to clarify?
And then after it gets converted to that language, then it enters the spooler?
Yes, once the file is converted by the driver, it enters the print spooler, which queues and sends the job to the printer in order. Let me know if you need more detail
But
on.
we see it inside the spooler as a file still?
Yes, inside the spooler, it's essentially queued as a file waiting to be processed and sent to the printer. Need help with anything else?
But does it go spooler, and then once it's ready to be processed, then it gets converted into a PDL, or?
The driver converts it to a printer language before it enters the spooler. The spooler then queues that already formatted data until the printer is ready to print.
So, but it's formatted data inside the file, like the file. If we were to click on the file that's inside the spooler, it would just be in a programmable language.
Exactly. If you examine a file in the spooler, it's already in a printer language like PCL or PostScript. It's not human readable, but ready for the printer to interpret.
Okay.
Let me know if you need help with anything else. I'm here if you need anything else explained or clarified.
In this lesson, we're going to talk.
Take your time. Let me know when you're ready to dive into something else.
So really, the hypervisor is creating virtual machines, not really OMs, right? And then the sorry, not OSs. The OSs just exist within the virtual machines typically. Are each virtual machine going to have their own BIOS and UEFI separate from the OS as well, or no? Okay, and then each OS can have multiple containers. Now I just need to understand the OS. So does okay? Yeah, I don't think that's really relevant. Okay, so Yeah, so the containers are the application, and I can just understand this as code. A hypervisor is literally a block of code, right? That's like specifically what we mean by hypervisor is the block of code that does a thing. Yeah, okay, so the OS is also a block of code. Hardware is not a block of code. And then the virtual machine isn't really a block of code either. It's just a thing that consists of blocks of code. It's like the location where all the blocks of code happen. Or is a virtual machine a specific block of code? Oh, why am I doing this? Okay. So the hypervisor is code, the OSs are all code, the containers are all code. The virtual machines are just the things that host the block of code, or they are themselves a block of code. Like they're the thing, sorry, not the things that host the block of code. They are just the totality of the blocks of code is considered the virtual machine, like the OS plus all the applications and that stuff is considered the block of code, or yeah, or it's just a virtual machine is by definition just like the thing, the like sort of like the virtual location, the virtual isolated environment where all the blocks of code exist within. Wait, so the virtual machine exists within hardware, or the hardware exists within the virtual machine? Sorry, software, that's what I meant. Basically, the hypervisor exists separately from the virtual machines. The hardware exists separately from the hypervisor. And then the OSs and containers all exist separately from the hypervisor, but they all exist together within the same virtual machine, right? Okay, and then inside the containers, you have um, um, or actually, I don't need to delete those. Okay, so inside the container, all that you have is the application and the supporting software that's required for the application to run, right? That's all. And it's a virtualized environment because it's like typically you have the user, but the user like the thing that's confusing to me is that the user interface or the user space to me is what the virtual machine is. Like the virtual machine is the user space. So is it just like a user space within a user space or something like that? But do they mean, because to me it feels like they don't, when they say containers are a form of virtualization, they're not saying that it's they're not just saying it's like an isolated environment, they're saying something else, and that's what I'm trying to figure out. The thing, like I still don't understand because like a virtual machine is virtual because it has virtual hardware, right? Like the hardware itself is virtual. It doesn't really exist the way that the virtual machines are using it. But the containers, to me, all the stuff within the container does exist the way that the containers are seeing it, or something like that. Or it's just virtual because there's like boundaries within the other applications. Like that stuff does exist, but it's like it's virtual in the sense that it exists like separate from it, like as if it was its entire own user space, like it was a full user space. But that part's not real because the entire user space exists outside of that, but you virtualize it in the sense that makes it seem like it's its own virtual space or something like that. So containers provide the illusion of a full environment, but I don't understand how it's providing the illusion of a full environment because it's like, is it like almost another another virtual machine or something like that? Okay, so it's like a virtual, it's almost like a virtual computer within, it's almost like each virtual machine has their own virtual space within that virtual machine, and those virtual spaces are called containers. But each container is like a virtual space, right? Instead of a virtual machine includes kind of like the hardware, but the containers are a virtual space because it's not really about the hardware. It's like about the own like user space. Like it's like typically in a computer you have a space where everything interacts with each other, but in a container you have that you have that same thing, but it actually exists within the real space, and the containers are just like a virtual space that doesn't interact with outside that. But the part that's virtualized is the space, right? Okay.
Talk about containerization. These days, the newest type of virtualization that we're seeing in our networks is known as container-based virtualization, or more commonly called containerization. Now, containerization is a type of virtualization that's much more focused on servers instead of the end user. With this type of virtualization, the operating system kernel is...
He says it's mostly focused on servers rather than the end user. What does that mean? No, but he says that containerization is mostly focused on servers instead of the something. So he's basically saying it more commonly happens in server environments.
Going to be shared across multiple virtual machines, but the user space for each virtual machine will be uniquely created and managed. Containerization is a great type of virtualization that can be applied by host operating systems to provision an isolated execution environment for a given application. Containerization is considered fairly secure because it enforces resource segmentation and separation at the operating system level. Containerization is commonly used with Linux servers, and some examples of this container-based virtualization include things like Docker, Parallels Virtuoso, and the OpenBZ project. So, what does it look like when we use containerization? Well, you're going to have a piece of hardware, and then on top of that hardware, you have a host OS, and usually this is going to be Linux. And then you have a container manager, which is something like Kubernetes or Docker or something like that. This container manager is going to be used to create different containers that contain different applications that are hosted on top of this operating system. In this case, I have 3 containers. I have the first environment, which is based on the kernel of the host OS, and in this example, that's the Linux system that's being used. And so we have container 1 running Linux, and it contains some applications there. Then I have container 2, which is doing the same thing. It's running Linux, but it has a different set of applications in their own container. And then I have container 3, which is also doing the same thing with a different set of applications. Since all 3 containers are sharing the same underlying host operating system files, this takes a lot less resources than if I did pure virtualization using 3 separate virtual machines. So if we instead use individual virtual machines instead of containers, we would need to have a separate operating system for each of those 3 containers or 3 virtual machines. And that could take an extra 10 or 20 gigabytes of storage for each of those containers. Now by using container, it takes a lot less resources. Then I have container 3, which is also doing the same thing with a different set of applications. Since all 3 containers are sharing the same underlying host operating system files, this takes a lot less resources than if I did pure virtualization and host operating system files of applications. Since all three containers are sharing the same underlying host operating system files, this takes a lot less resources than if I did pure virtualization using 3 separate virtual machines. So if we instead use individual virtual machines instead of containers, we would need to have a separate operating system for each of those 3 containers or 3 virtual machines. And that could take an extra 10 or 20 gigabytes of storage for each of those containers. Now, by using containers, though, we can use the same underlying operating system, and in our example, that's Linux. This means that containerization uses a lot less storage space and takes a lot less processing power than does a traditional virtual machine or traditional virtualization. And this is really the real big benefit of using something like a container from an operational perspective. Also, because these containers are logically isolated, they cannot actually interface with each other. So if I want container 1 and container 2 to talk, I actually have to connect them through a virtual network and do the right routing and switching to allow them to communicate. By default, these containers have no way of talking to each other, and this is a great thing from a security standpoint because we have built-in segmentation. All right, now we're going to talk about the bad side of containers, and here's your big warning when it comes to dealing with containers. If the attacker can compromise the underlying host OS, for example, that Linux operating system I was just discussing, then guess what happens? Well, this attacker now has access to all of the containers and their associated data because they're all sharing that one operating system. This is the biggest vulnerability you're going to see when you're using containers, so keep this in mind. If you have a containerized system that's running 50 different servers right now, and each of these is running different servers and services and applications using different containers, that's great. But if somebody can get to that one server underneath that's running Linux, that now gives them access to all 50 of those hosted containers and their associated data. Now, another big risk to consider is how your containers and other virtual machines are going to be hosted.
When he says that if the underlying OS gets compromised, then all the containers will be compromised as well, is he saying like why is that?
Is compromised, that means someone has control over the host machine itself. Since containers share the host's kernel and resources, an attacker could potentially access or manipulate any containers running on that host.
Well, why the OS is just a block of code? Why does it give you access to everything else?
Because the operating system manages all hardware and resources. If it's compromised, an attacker can control what containers do and access their data.
That's because the OS manages everything. Part of the OS is its interactions with those other things. The thing that's like confusing to me is like, I guess you can control what the OS does, and then that controls the containers. But in order to see what else everything exists on that let's say virtual machine, or just the machine itself, the regular machine, seeing the stuff is different than controlling the OS's like signals and stuff, right?
Exactly. The OS is like the central traffic controller. If someone compromises it, they can intercept or modify signals to all containers and processes. Observing what's on the machine just requires read access, but controlling the OS means you can dictate how...
But being able to have read access is something that the OS gives you, or...
Yes, the OS controls permissions for reading and writing data.
Now, once we begin to rely on virtualization and cloud computing, it becomes really important for us to recognize that our data might be hosted on the same physical server as somebody else's data. And by doing so, we're now introducing some other vulnerabilities into the security of our systems. First, if the physical server crashes because something one other organization does on that physical server, it's going to affect everybody else who's sitting in that same server. Think about it like if you live in a condo. If somebody catches their condo on fire, it affects the other 50 units in the building because we're all sharing the same building, even though we have individual rooms or individual apartments or condos inside of that building. This is the same idea here when we're all sharing the same physical server. Similarly, if one of the organizations is not maintaining the security of their virtual environments that they're hosting on that physical server, there is a possibility that the attacker could utilize that to the detriment of all the other organizations hosted on that same physical server. Now, just as there are security concerns when we interconnect our networks with somebody else's, we also have to be worried about hosting our data on the same physical servers as other organizations. Therefore, it's important for us to properly configure, manage, and audit our user access to our virtual machines that are being hosted on these servers and really make sure they're locked down and well containerized. Also, we want to make sure that we ensure our virtual machines have the latest patches, antivirus, anti-malware, and access control in place to ensure we're not being attacked. In order to minimize the risk of having the physical server resources being overwhelmed, it's also a good idea to set up virtual machines with proper failover, redundancy, and elasticity as well. By monitoring our network performance and our physical server's resources, we'll be able to balance out the load across several physical machines instead of just relying on a single one if needed. So, when should you consider virtualization or containerization, and which one should you use? Well, first you should ask yourself, am I going to use traditional virtual machines in virtualization, or do I want to move into the world of containerization? This decision is really one that you need to balance the risk versus the reward. Remember, this is a balancing act of getting better performance by using containerization, but you're now also risking that an attacker could compromise all of your containers at once by attacking that underlying hypervisor or shared operating system.
So if they get access to the hypervisor, they get access to all the virtual machines as well, right? And what's considered easier to get access of as a hacker, the OS or the hypervisor?
It's really one that you need to balance the risk versus the reward. Remember, this is a balancing act of getting better performance by using containerization, but you're now also risking that an attacker could compromise all of your containers at once by attacking that underlying hypervisor or shared operating system. This really becomes a business decision and a cybersecurity decision, and we're going to have both of these things playing at us, so we have to balance them. We have to measure these things and decide what is best for our particular organization and our specific use cases. So remember, containerization is a type of virtualization that's being applied at the host operating system level to provision an isolated execution environment for a given application or applications. Containerization is considered to be fairly secure because it does enforce resource segmentation and separation at this operating system level. Containerization does provide better performance than traditional virtualization, but it does provide us a single point of vulnerability by relying on a common shared operating system for all of our containers instead of using individualized versions of each operating system for each and every one of our virtual machines that's being operated. In this lesson, let's explore the purpose of virtual machines, or VMs. Now, for cloud computing to gain its intended cost savings and efficiencies, it relies heavily on virtualization. By using virtualization, numerous logical servers can be placed on a single physical server, and this in turn reduces the physical amount of space, power, and cooling that's going to be required inside of our data centers. Additionally, by using virtualization, we can achieve higher levels of availability by spinning up additional virtual servers whenever we need them. This ability to dynamically provision memory and CPU resources is one of the key benefits to cloud computing. Now, while there are many different benefits to cloud computing, there are still numerous security issues that we need to consider. Now, most of the same security issues that we have with physical servers will also be carried over into our cloud-based environments. Oftentimes, executives think that moving to the cloud is going to solve all of their problems, but this is never really the case. When we're using virtualization, one or more logical servers will reside on a single physical server. And to accomplish this, we use specialized pieces of software known as a hypervisor. A hypervisor controls the distribution of all the resources, such as the processor, the memory, and the hard disk space. Essentially, the hypervisor emulates a physical machine, so the operating system and all of its applications don't even realize that they're operating inside of a virtual environment. Hypervisors are divided into two categories: Type 1 or bare metal hypervisors, and Type 2 or hosted hypervisors. When comparing bare metal hypervisors against a hosted hypervisor type, the only main difference from a security perspective is with the hosted types that we have to ensure the underlying operating system is also properly secured and patched. From a performance consideration, bare metal is going to be faster and more efficient than a hosted counterpart. Another virtualization option we have is what's known as container-based virtualization or containerization. With this type, a hypervisor isn't utilized at all, and instead, each container relies on a common operating system as the base for each of those containers, while each container shares the same underlying operating system, and each container has its own binaries, libraries, and applications that can be customized for their specific needs. Currently, container-based virtualization is almost exclusively used with the Linux operating system as that underlying operating system. Containerization also uses less resources than a typical Type 1 or Type 2 hypervisor because it doesn't require its own copy of the operating system for each individual container like you would with virtual machines. Many cloud service providers have taken virtualization a step further by using hyper-converged infrastructures. Now, hyper-converged infrastructures allow the provider to fully integrate the storage, networks, and servers without having to perform hardware changes. Instead, they rely on software and virtualization technology to perform all of the integrations for them. This allows us to manage all of this from a single interface or having a device without having to worry about all the
Hyper-converged infrastructure? I don't understand.
underlying vendor solutions. Application virtualization is yet another type of virtualization that's commonly used to create additional security for our underlying host. Application virtualization is a software technology that encapsulates computer programs from the underlying operating system on which they're being executed. A fully virtualized application is not even installed in a traditional sense on your system, although it still is executed as if it was.
So what's the difference between application virtualization and containers? Are application virtualization, is that just the code for the physical application is existing on one environment, but it's being accessed and used on a remote environment? So essentially, the app, the everything that contains the app except for the display, like the only part of the application that you are accessing directly on your computer is the display. And is that done through RDP?
With application virtualization, you can run legacy applications that were designed for end-of-life operating systems like Windows XP or Windows 7 on top of a more modern operating system like Windows 10 or Windows 11, or you can even run cross-platform software such as Android applications on a Windows machine by using this type of application virtualization.
Oh, application virtualization allows you to do that because your OS isn't the thing that's running it. Wait, how would you do application? What, I don't understand. Client-based application virtualization? Isn't that just not application virtualization? But it's still running through your OS, right? I still don't understand client-based and server-based, like virtual application. If I'm doing a client-based, this is how I think it occurs, right? The application needs to like process, like the input and stuff needs to process, the code needs to interact, whatever, and do things. Those things happen in server-based virtual application Those things happen on a server, and then the output gets sent to your device and it gets displayed. And then you do the input, that gets sent to the server, the processing happens, and then it comes back to your device. But with client-based, to me, it sounds like that processing happens on your device locally. So you send the output from your local device, then the processing happens on your local device, and then the output happens on your local device. But how is that different than just regular application? Keep going. Say what you were saying again. Oh, interesting. That's interesting. Okay, so containerization. Okay, so with virtualization with virtual machines, you have the OS, which directly interacts with the container manager, which directly interacts with the containers, right?
Not exactly. Virtual machines run on a hypervisor, which sits on top of the physical hardware or host OS. Containers are different. They share the host OS kernel and use a container runtime, not a hypervisor. They're lighter weight because they don't need a full OS for each container.
But they have they have a container manager or no?
Yes, containers use a container runtime or manager, like Docker or Containerd, which handles launching and managing containers. This runs on top of the host OS, sharing the host kernel.
Yeah, so the OS interacts with the container manager, and then the container manager interacts with the containers, right?
Exactly. The host OS provides resources, the container manager or runtime orchestrates and isolates containers, and each container runs its own application stack using the host OS kernel.
And then can you help me understand how that is different? So the OS interacting with the containers is different than application virtualization, where the OS isn't really interacting with the applications. Like in containerization, the OS is interacting with the applications, but in application virtualization that's client based, somehow you're not interacting with your OS.
In client-based application virtualization, your OS runs a lightweight client, while the app is actually packaged and isolated. The client interacts with the virtualization layer, not directly with the app's processes. Containers, on the other hand, are integrated with the OS kernel, but isolated from each other. The OS directly provides resources to...
Wait, help me understand application virtualization. So we have the OS.
In application virtualization, your local OS runs a client that displays the app interface.
And client-based application virtualization can exist within a VM2, right?
Client-based application virtualization still runs on your OS, but the app is isolated in its own container.
But it can exist within a virtual machine. It can occur within a virtual machine, or no?
Yes, it can.
Okay, so with application virtualization, you have, let's say it exists within a hypervisor. So you have the virtual machine, then you have the OS that runs the virtual machine, and then you have the application, then you have the app, and we're talking about server-based application virtualization. Sorry, client-based.
On your machine, but it still uses your OS resources. The virtualization layer keeps it separate from the rest of your system, preventing conflicts. The difference from server-based is that all processing stays local, while server-based runs the app remotely and streams the interface.
Wait. So you have the application, which exists inside of the virtual machine, right? The client-based application, the virtualized client-based application, right?
Yes, in a client-based scenario, the virtualized application runs inside the virtual machine,
Okay, and when you say it's isolated the same way. It's isolated the same way that a container is isolated.
Similar idea, but not identical. Client-based application virtualization isolates the app's files and settings from the OS to avoid conflicts.
Well, okay, what do you mean I don't understand what that means. It isolates the app's files and settings from the OS? Like, what does that mean? The OS can't see the app?
Isolation means the app runs in its own sandbox. It still uses the OS to execute, but its files and settings are kept separate, reducing conflicts and making cleanup easier.
Okay, so in the OS, in normal containers, the OS can see everything that exists within the container. But in client-based application, the OS cannot see the application itself. It can only see the signals that it's receiving from the application.
The OS can still see the application's processes, but the application's files, settings, and registry entries are kept separate in a virtual layer. This isolation prevents conflict and makes it easier to manage and update.
Okay, so the app is directly interacting with the part of the app is directly interacting with the OS, but then you also have the app's, like, what can we say, like major settings, or like how do I describe that?
Think of it this way. In client-based application virtualization, the app's files and settings are stored separately, so they don't alter or depend on the host OS's configuration. The OS can run it, but the application has
So what is the OS seeing if not the files and settings?
In client-based application virtualization, the OS sees the virtualized app as a single isolated process, but it doesn't directly access its installation files or registry entries. Those are stored in a sandbox, essentially a controlled environment that manages the app.
Sorry, say that again.
Sure. In client-based application virtualization, your operating system sees only the application's interface and behavior, while the app's files and settings are isolated in a virtual layer. The OS doesn't manage or access those internal files directly, it just runs the virtualized app as if it were normal. The virtualization layer intercepts interactions, so your OS sees input and output, but not the underlying file structure.
And is that the same thing with server-based application virtualization, except for it's not your OS that's running it, it's their OS, but they can still see, their OS can still see your app and stuff like that. They just can't see your app's files and settings.
Exactly. In server-based virtualization, the application runs on the provider's OS, which manages the files and settings. Your device just displays the interface and sends inputs back, but you still don't see those internal files directly.
But I can see, my OS can see the app, but it can't see the app's files and settings.
That's right. Your OS sees the application interface and processes, but the virtualization layer keeps the app's files and settings separate and protected. Anything else you'd like to clarify? Let me know what else you'd like to go into, whether it's how the server handles the app.
But one of the tasks that gets inevitably delegated to some relatively new hire at an organization is actually going through and getting an inventory of all the applications that are in use. That may seem crazy. I mean, don't we know what applications we're running in a company? But over time, the number of applications, the versions of those applications can get out of control. And one of the tools that virtualization can bring into play to help mitigate that issue is literally called application virtualization. So let's talk for a minute about what that is and how that fits into the big picture of being a virtualization administrator. When most of us think about an application, what do we envision? Probably some sort of window that opens up. And behind the scenes, we might be aware that, well, the reason why that window opened up and a particular exciting program opened up for us is because, well, all of the binary bits that make that program up are stored on a disk. And then those bits get loaded into memory and then are processed by the CPU. And all of that is happening through what? Through the local operating system, grabbing all those pieces and manipulating them and making them happen. We said the challenge for an enterprise administrator is the fact that there's a lot of operating systems out there that have existed over time. And so the question is, well, which applications are available? Ensuring that the right applications are installed on our systems is important for the perspective of compliance, security, and stability. So application virtualization is all about coming up with a system, grabbing all those administrator. When most of us think about an application, what do we envision? Probably some sort of window that opens up. And behind the scenes, we might be aware that, well, the reason why that window opened up and a particular exciting program opened up for us is because, well, all of the binary bits that make that program up are stored on a disk. And then those bits get loaded into memory and then are processed by the CPU. And all of that is happening through what? Through the local operating system, grabbing all those pieces and manipulating them and making them happen. We said the challenge for an enterprise administrator is the fact that there's a lot of operating systems out there that have existed over time. And so the question is, well, which applications are available? Ensuring that the right applications are installed on our systems is important for the perspective of compliance, security, and stability. So application virtualization is all about coming up with a new way for those applications to be deployed and consumed. Now, for the most part, we're not trying to create anything too radical in terms of how the user experiences an application. We still want to give them a window with a program that they can open, launch, execute, run, close when they're done. So the virtualization aspects are going to be the things that are behind the scenes. There's a couple of different ways that application could be launched. One method is for the client to launch an application which triggers a connection to a remote server. And that and it is actually that server that goes through the process of finding the binaries, loading them into memory, and using the server's CPU to provide that application. But the display of that application is not being viewed on the server. The display is coming right back down to the client so that they can see the window that they would normally see and interact with it just like they normally would. The interesting thing about this is that multiple users could connect into this one server that has the application installed in such a way as to support multiple users connecting, and each of these users could be independently running that application, seeing their own personal window. This means that the application doesn't have to be deployed 10,000 times for 10,000 users, but just enough times on enough servers to support those users connecting in. This actually increases the weight of responsibility on a network to support these connections going back and forth. You literally can't run the program if you don't have access to the network. But it decouples the application from the box that the user sits on. So this first style of application virtualization often goes under the term of terminal services, or a remote desktop experience. But it's not the only form of application virtualization. Sometimes applications don't work well when you've got 10 users all actually running the one same binaries in memory 10 or 15 times over. So in those situations, another technique might be available wherein the user, once again, launches an application on their desktop, but they connect to a virtualization host. What does a virtualization host provide? Virtual machine. And it's going to be the CPU, RAM, and disk available within that virtual machine that is used to launch the application that is needed. But that application is viewed on the user's desktop. They don't have to see the whole VM, they just see the one application that they launch, and they're happy as a clam. So this is called desktop virtualization. And again, the advantage is if there are 10 users, there will be 10 virtual machines being used to provide those applications. But this means that there could be 40 users, but if only 10 of them need to use the application at the same time, then those 10 separate virtual machines can provide a complete isolated experience.
Oh man, I'm confused. I'm confused.
Experience for that application to run correctly. correctly. And again, I didn't need to deploy it to any one particular desktop. A user could move to a different users connecting, and each of these users could be independently running that application, seeing that fits into the big picture of being a virtualization administrator. When most of us think about an application, what do we envision? Probably some sort of window that opens up. And behind the scenes, we might be aware that, well, the reason why that window opened up and a particular exciting program opened up for us is because, well, all of the binary bits that make that program up are stored on a disk. And then those bits get loaded into memory and then are processed by the CPU. And all of that is happening through what? Through the local operating system, grabbing all those pieces and manipulating them and making them happen. We said the challenge for an enterprise administrator is the fact that there's a lot of operating systems out there that have existed over time. And so the question is, well, which applications are available? Ensuring that the right applications are installed on our systems is important for the perspective of compliance, security, and stability over time. And so the question is, well, which applications are available? Ensuring that the right application.
I don't understand when he says which applications are available. What is he talking about?
He's talking about making sure only the approved, needed applications are installed and accessible on the organization's systems, so they can maintain security, compliance, and consistency.
Why? What does it mean for an application to be like the right? I don't understand.
An application is considered the right application when it meets the organization's needs and complies with security, licensing, and compatibility requirements. IT administrators keep track to ensure software is safe, properly licensed, and compatible with their systems. This helps avoid unauthorized or outdated apps that could cause security or performance issues.
And so we have the apps. We have the so it's who is worried about these apps?
Typically, IT administrators and security teams are the ones concerned. It sounds confusing.
IT administrators.
Yes, IT administrators are the ones responsible for ensuring the right applications are installed and secure across the organization.
What organization? The IT administrators of the organization.
Yes, IT
Okay, so a given organization. Can you give me an example?
Sure, think of a hospital. Its IT administrators manage which medical
Okay,
software.
so hospital. A hospital, that's who this application virtualization could help, right? Because they ensure the hospital makes application virtualization ensures that right applications exist or what?
Application virtualization ensures the hospital's users can run needed apps without installing them locally. The IT team controls which apps are available.
Wait. No, well, what's the general goal that they have outside of virtualization? I know virtualization helps this goal exist, but what is the goal?
The goal is to control and standardize which applications are used, ensuring they're secure, compliant, and supported. Virtualization helps by delivering.
Ensures the applications is to have good applications, and what makes an application essentially that only good applications are running or exist or what?
IT administrators aim to ensure that only authorized, secure, and compatible.
Stop. I just want, what is the goal of the hospital?
In a hospital, IT administrators aim to ensure that only secure, compliant, and functional applications are available to staff. This keeps patient data safe, meets regulatory requirements.
Okay, so the hospital wants only good applications to exist or good applications to be running from the hospital's like computers or like I just need to be more specific. Like you're going too broad.
Sure. For example, and to protect sensitive data.
Sorry, say that again.
IT admins at a hospital use application virtualization to deliver approved software, like patient record systems, to many computers. This ensures only those.
So essentially, more specifically, what they want is they want people not doing bad stuff on you through like people not doing bad stuff.
Right. They want.
I don't. Okay, so basically, the hospital has this goal of bad stuff not happening, right? I just got to start super surface level. They don't want bad stuff to happen. Uh, uh, not bad stuff. They have the goal of bad stuff not happening, right? And an example that has a lot of different things that encompasses, right? So they have that goal of the bad stuff not happening. An example of that would be bad software, or like bad what would be an example of that in the context of what we're talking about?
For a hospital, an example of bad stuff could be staff accidentally using unapproved software that could expose patient data or downloading malware that compromises systems. Application virtualization helps.
Wait, you're going too far. I just want to stay on step one. So they don't want patient data to get exposed, right?
Exactly. They want to prevent patient data from being exposed or mishandled, so they control which application.
Okay, that would be an example of patient data uh, being exposed. That would be a bad thing that could happen. Okay, and so application virtualization supposedly helps that goal, right? The solution is application virtualization, right?
Yes, application
Okay. Now
virtualization is the solution.
before we go into why that helps, what is the thing that would expose the patient data? Like, how would patient data get exposed? What would be an example, like a thing that the application virtualization would help prevent? So, like, for example, someone sending the patient data. Like, I would think like someone sending, literally just emailing the patient data out or something like that.
Exactly, like an unauthorized email with patient records, or installing
Would
malware that
application
steals data.
virtualization would help with that, or because like the emails is like an application?
Yes, exactly.
Okay, so let's stay on that. So sending an email of patient data, right?
Yes, email.
Okay, and application virtualization, what it does is what?
It delivers approved applications from a central server, so staff can run them without installing or managing them locally.
Delivers application delivers approved applications
Yes, it delivers approved applications from a controlled server environment, so only trusted software runs. This helps prevent
from controlled server. So basically, oops. So basically when uh the process would be like, hold on. So basically the process would be like uh um
in,
basically the
in simple terms,
stop.
understood.
So basically the process
The
the
process
pro stop.
to keep it
Basically the process, I'm making myself. Why isn't this
I'm,
stop. Okay, so basically the process that would happen is hold on.
it works by
Okay, so the way the process would happen is like the person wants to use email, right? So like person I want to understand the normal way it would happen, and then the way the application virtualization is different. So person wants to use Gmail. That's the application. Wants to use Gmail. Okay, so person wants to use Gmail. So normally without application virtualization, they would do what?
normally staff would install and run email directly on their PC.
Install and run Gmail on PC. And what does that mean?
Without virtualization,
No. What does it mean for Gmail to be installed and run on the PC? Like, I just don't even really know what that means.
when Gmail is installed and run on a PC, it means the program is directly on that computer, using its resources and storing data
But what
locally.
does it mean for the program to be directly on the computer? Like the data, the date, like basically Gmail is just a bunch of code, or it's a bunch of bits.
When Gmail runs on your own computer, the code executes locally. Your device downloads data, stores temporary files, and handles the processing.
Okay, so like Gmail consists of data. That data exists on your PC.
Right. When you run
Okay, so that's what we mean when we install and run Gmail, is that we are installing the Gmail data, and then that data is like changing on our PC, right?
exactly. When it,
Okay. So we install Gmail's data. What is the difference between download and install? Are they used interchangeably?
downloading means you're just copying the setup files to your device. Installing means actually running those files so the program is set up and
So
ready.
install and run is redundant now.
They're related but not identical. Downloading gets the program files, installing sets them up on your PC, and running executes the program.
Okay,
And
install and run So is it really when a person wants to use Gmail, they have to download, then install, then run Gmail?
for web apps like Gmail, you usually just access them through a browser, no installation needed. Installation is more relevant for software that runs locally.
So does Gmail, is that because Gmail uses application virtualization?
Gmail itself is a web-based app, so it runs on Google servers, and you just access it through your browser. That's not application virtualization.
Okay, what's an app that what's an app that a person could use to expose data?
Examples include locally installed email
Like what
clients.
about maybe WhatsApp? Or is that similar to Gmail?
WhatsApp is similar in that if you're using the web version, it's accessed through your browser. But the desktop app stores data locally, which could expose information if the system's compromised.
Okay, so I'm just trying to figure out what's a good app that could expose data that also application virtualization would help.
A good example is a desktop email client like Outlook. It's
Okay, so Outlook doesn't work like Gmail.
Outlook's desktop version installs and stores data locally, which makes it more vulnerable.
Okay, so let's do that one then. So Outlook. Okay, a person wants to use Outlook. So in order to use Outlook, they need to download, install, and run Outlook, right?
Yes,
Download. So they download the data, which means now all the data for Outlook exists on your PC, right?
exactly.
And then install means you just set up the data so that you can use it.
Exactly.
And then run just means that you're using the data, meaning you're like kind of like manipulating it, right?
Right. Running.
Okay. Okay. All right. So now we download, install, and run Outlook, and what that really means, is that we receive the data probably through some like through the internet, right?
Yes.
Receive data, set up data, and use/manipulate the data.
Right. Running.
Okay. Manipulate the data. Okay, and then when you do that, the thing that you could do that's bad is you can just send patient data using that application, using Outlook.
Exactly.
Okay, all right. So now let's go the same process, but now we're using application. We're using application virtualization. So person wants to use Outlook. So now what happens? Instead of them downloading and installing and running Outlook on their computer, something else happens, right?
Yes. With application virtualization, Outlook runs on a server, and you interact with it remotely.
Wait, hold on. Receive data, set up data, and use/manipulate data on the PC, which is really on the hard drive. Oh, yeah, like it's just on the PC, okay? Because it's like through RAM, CPU, all that stuff. So, anyways, person wants to use Outlook. So what happens?
When someone uses Outlook, they typically download the installation files.
No. I'm saying if they're using application virtualization.
In that case, the Outlook app would run on a remote server. You'd stream the interface to your
So
device.
you don't download or install or run Outlook at all.
Exactly.
Okay. So Outlook is downloaded, installed, and running on a remote PC.
Right. Outlook.
Okay, hold on. On local PC on PC, sorry, excuse me. On a remote PC, which just means that the same process is happening. The same process is happening. The same exact situation. Hold on, hold on, hold on, hold on. There we go. Okay, so the same situation happens.
In the same
Stop, 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 stop.
No problem.
Boom, boom, boom. Oh shit. Okay, so that same on receive, setup, and use/manipulate data on the remote PC. Okay, cool. So now when the patient can still send the patient data uh, using Outlook, essentially, right? It's just that now, because it's being run on that server, we can now see that is occurring or something like that.
Yes, administrators can monitor and control what happens on that server, including data access.
So it's just instead of like using, because you could basically you can monitor and manage all the applications that exist on your PC easier because the people are using your PCs. So like if you have like 100 different computers inside the hospital, every single application that each computer is using, if you're using application virtualization, you are actually have full access to all of those things, right? But
Exactly.
couldn't you just use something like an MDM, which does the same thing, but it's just is application virtualization just like cheaper or like requires less stuff to go on or something or what?
Application virtualization and MDM solve different problems. MDM manages the devices themselves, while application virtualization centrally hosts and delivers apps from a server, reducing installation and maintenance on each device. It's not necessarily cheaper, but it can simplify.
Oh, so it can help with security because it lets you manage it, but also it doesn't. The primary purpose is not just security, but it's also to save money on processing.
Exactly.
Okay. Um. Okay. And then what else? It's compliance is also to make sure the right apps are running, but that's a security thing, isn't it?
Yes, compliance helps ensure only approved apps run, which ties into security, but it's also about meeting regulations and standards. Interested in more details from this video?
Are installed on our systems is important for the perspective of compliance, security, and stability. So
What is stability? I don't understand that.
Stability refers to how consistently the virtualized apps perform without crashes or unexpected issues.
Oh.
It means that virtualized apps run
And
consistently.
compliance. So, but couldn't you use an MDM to do compliance as well?
MDM can help with compliance by managing devices, while application virtualization focuses on delivering apps from a central server. Together, they can complement each other in security and compliance.
But I'm saying both of them allow you to control what applications are being used by that device, right? A computer is a device, right?
Yes, both MDM and application virtualization give you control over which apps can be used on a device, whether it's a computer, phone, or tablet. Want to dive deeper into any
Wait,
particular?
I want to understand. I understand the difference of what's going down on the the basic level, but I'm just trying to also understand what is happening on the extended level. So the extension of each is that they both allow you to ensure compliance, security, and maybe not stability, but compliance and security, right?
Both application virtualization and MDM help with compliance and security, but they do it differently.
I know
Virtualization
that they do it differently. I'm not worried about that. I'm just worried about what they actually accomplish. Don't they accomplish kind of the same thing, except for with application virtualization, you just save on hardware?
Application virtualization can reduce hardware costs because it centralizes app processing on servers, so individual devices don't need as much power. MDM, on the other hand, focuses on enforcing policies and compliance.
So now what I want to know um, is what is the difference between client-based application virtualization and server based, because client based doesn't really help with stability, right?
Client-based application virtualization runs the app on the user's device, but isolates it from the rest of the system, making it easier to manage and reducing conflicts. Server-based
So it
runs
helps with client based helps with compliance and security, but it does not help with stability.
Client-based virtualization primarily helps with compliance and security, but it doesn't provide the same stability improvements as server-based virtualization.
Right, because you're just running. It's all happening on your same OS. It's just more isolated.
Client-based virtualization isolates apps on the user's machine to reduce conflicts and improve manageability, but it doesn't improve stability in the same way server-based solutions do.
Okay. Okay. All right. So server based just means all right, so let me just I need to compare client based I need to compare client based with server based. So each of them are going to have hardware. Each of them are going to have OS. Now, now it's going to be and the OS and hardware are going to be kind of like connected, right? And then client based is using your OS. Sorry. Hold on. Why isn't Control Z helping? Oh, there we go. Maybe I just wasn't hitting the right button. Oh yeah, I probably just wasn't. Okay, so yeah, so client based uses your OS versus oh wait, hold on. Server based. So you have OS. So oh dang. Okay, so we need more variables here. So uh, okay, so client based, server based, server. Okay, I can just server, server. Okay, and then client. Okay, and now we'll go boom and boom. Okay, cool. And then we can go boom. Okay, cool. So boom, boom,
Server
boom. Okay, so we have in both situations, in the client one, you just have your own OS and hardware. Now in the server one, you have your own OS. You have your OS and hardware, but then you also have a server's OS. So we'll call it OS S, and we'll call it hardware S. Okay. Um, sorry. Okay, so this is the server's hardware. Um, and then you have the app that's running in a way using your OS, right? Because yeah, right. Well, I guess it's not really running using your OS, but the display uses your OS essentially.
client-based application virtualization runs the app locally on your OS, isolating it but still relying.
I'm talking about server.
In server-based application virtualization, the application runs on a
So,
anything.
but the display runs on your device, right?
Yes, with
Okay, so display plus display plus input, is it related to the app, is what you do through your OS, right?
exactly. In
Okay.
server
Okay, so display plus input, and now the OS on the server is going to do the processing, right?
correct. The
So
server
so the processing, it's going to be, yeah, it's going to, yeah, processing, which is like the main chunk of, yes, processing. Okay, cool. So and now so server-based application is good because uh because all the processes being happening on the OS, so that they can control, like, if this is like secure, if this is compliant, they can just not process it, I guess, right?
right. The server side lets administrators control which applications run, apply security policies, and restrict or deny processing if needed.
So processing plus management.
Yes, management happens on the server side too. The server controls updates, security, and who has access to the
As for application server-based application virtualization.
Server-based application virtualization hosts the app on a central server, keeping it secure and managed there, while client devices.
Okay, so now client-based application, you have your OS and you have your hardware, and then you have your app. And the OS is going to be interacting directly with the app, but it will not and it cannot interact with the files and settings.
Right.
Okay. But it's doing the processing and stuff. Now, for server-based application, can the server interact with the app files and settings, or no?
Yes, in server-based virtualization, the server can access and manage the app's files and settings since the app runs in that controlled environment. Your device mainly handles display and input.
But in client-based, you can't. Your OS can't access the files and settings. So then what can access the files and settings? Are they just not accessible?
In client-based application virtualization, the app's files and settings are isolated from the host OS, so they're not directly accessible to the OS or other apps. In server-based virtualization, the server manages those files centrally, allowing controlled access and management.
Wait, sorry, say that again?
In client-based virtualization, the app's files and settings are kept inside a sandbox, so neither the host OS nor other apps can reach them. In server-based virtualization, the server can fully manage those files and settings.
So wait, are they like, so can nobody edit them?
In client-based virtualization, only the virtualized environment itself can edit those files and settings, not the host OS. In server-based virtualization,
I don't understand that, because the OS needs to process that, right? Is there like a separate OS that's doing that, or like what is the thing that's doing that if not the OS in client-based? So you're saying that with client-based virtualization, the host OS, we'll call it host OS, the host OS is not is managing and processing the application, but it's not managing and processing the application's files and settings.
in client-based application virtualization, the host operating system handles the display and interaction, but the actual processing of files and settings can happen on a remote server or in
No, I'm talking about client-based.
In client-based virtualization, the application runs on the client machine, but the files and settings can be managed centrally or streamed to reduce local overhead. Does that clarify what you were asking about?
But I'm asking, can the host OS access the app's files and settings on client-based virtualization?
In client-based virtualization, the host operating system usually still has access to app files and settings because the app runs locally. However, organizations can control this by packaging the app so its settings and files remain isolated or centrally managed.
But what is client-based virtualization? I just want to understand, how is client-based virtualization different from normal use of applications? Because yeah, so like boom 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 boom.
Client-based
Okay, hold on. So if I go like this, boom, oops, boom, 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 boom. Okay, so
Sure.
so if I in regular, so there's client-based application virtualization, and then there's just regular use of applications, right?
Exactly.
So help me understand the difference.
Sure. In normal use, software is fully installed and runs on your local machine. With client-based application virtualization, the application might be streamed or packaged so it runs locally, but doesn't fully install. Files and settings are isolated or managed separately by the virtualization layer. This makes it easier to manage and update applications without directly altering the host OS.
Client-based virtualization experiment.
Virtualization technology allows us to run multiple operating systems on one single desktop at the same time. For example, you have a Mac OS desktop, and on that desktop, you're running Windows 11, Linux, Ubuntu, and other operating systems all simultaneously. To each individual operating system, it looks like the OS
machine that is used to launch the application.
Which one is application?
But
Which
that
one is client-based?
application-
Is it desktop virtualization or application streaming? Okay.
Virtualization often goes under the term of terminal application from the box that the user sits on. So this first style of application virtualization often goes under the term of terminal services, or a remote desktop experience. But it's not the only form of application virtualization. Sometimes applications don't work well when you've got 10 users all actually running the one same binaries in memory 10 or 15 times over. So in those situations, another technique might be available wherein the user, once again, launches an application on their desktop, but they connect to a virtualization host. What does a virtualization host provide? Virtual machines. And it's going to be this. So this first style of application virtualization often goes under the term of terminal services, or a remote desktop experience. But it's not the only form of application virtualization. Sometimes applications don't work well when you've got 10 users all actually running the one same binaries in memory 10 or 15 times over.
Okay, so he's saying it's not the only form.
Sometimes applications don't work well when you've got 10 users all actually running the one same binaries in memory 10
same binaries
10
in memory 10, 50, 100 times. I don't understand.
No problem. Imagine 50 people all running the same app. If it's fully installed locally, each instance uses memory separately. With virtualization or streaming, the system can manage resources more efficiently, sometimes sharing the same binaries and reducing overhead. That's what the speaker is getting at. Want me to summarize more about it?
15 times over. So in those situations, another technique might be available wherein the user, once again, launches an application on their desktop, but they connect to a virtualization host. What does a virtualization host provide? Virtual machines. And it's going to be the CPU, RAM, and disk available within that virtual machine that is used to launch the application that is needed. But that application is viewed on the user's desktop. They don't have to see the whole VM. They just see the one application that they launch, and they're happy as a clam. So this is called desktop virtualization. And again, the advantage is if there are 10 users, there will be 10 virtual machines being used to provide those applications.
So is desktop virtualization just when the application, when is application virtualization the client-based one? Is that just when you are using regular virtualization and you have an app within that virtual machine?
Application virtualization and desktop virtualization differ. Desktop virtualization runs a full virtual machine on your client device. Application virtualization delivers just the app in an isolated container without a full virtual OS.
But how is client-based application virtualization different than from containerization?
Client-based application virtualization isolates apps and their settings from the host OS, but they still run within the OS. Containerization, like Docker, packages the app and its dependencies into a container that can run consistently across different environments. Containers share the host OS kernel, while virtualized apps rely on the host OS to run. Both isolate applications, but containers are more lightweight and portable across systems.
I do not understand.
But this means that there could be 40 users, but if only 10 of them need to use the application at the same time, then those 10 separate virtual machines can provide a complete isolated experience for that application to run correctly. And again, I didn't need to deploy it to any one particular desktop. A user could move to a different desktop, the application would still be accessible because it's on the network. Once again, though, we do have to keep in mind this does increase the network traffic going back and forth. And then there's a third main type of application virtualization, and that's called application streaming. I stream, you stream, we all stream for app stream. So with application streaming, we launch an application, and then we're going to connect to an application hosting server, which has that application available. It's on that server's disk. And then that application is delivered to the desktop, where it can then execute and provide the user experience. So that means that we're putting some of the weight back onto the desktop. It's the desktop's disk that now is going to temporarily hold that application, and memory that will host the execution of that application and CPU that will process that application. The network load is on demand. When we first open up the application, that triggers the streaming download of that application to execute it. But even then, if an application has a certain amount of disk content that's associated with it, but to initially run it only requires, say, 50% of that file to be delivered, then only 50% is delivered at the initial startup. When a user needs to use a particular function or a particular option that then digs into some of the other remaining portion, then at that point, that will also be streamed down. But again, it's on demand. It's only once that extra feature is needed to provide the functionality that we're looking for. So as we look at a terminal service or desktop virtualization or application streaming method of application virtualization, what's the common denominator? Or to put it another way, if we're in an interview getting asked, so how would you describe application virtualization? What's our answer going to be? Well, here's our quick and dirty definition, my friend. Application virtualization is when client applications are hosted remotely, but are viewed as if they were installed locally. And because of that, applications are centrally stored and can be centrally managed instead of trying to track down every application installed on every single desktop.
Many cloud service providers will also offer something known as VDI, or Virtual Desktop Infrastructure. Now, VDI, in this lesson, we're going to cover virtualization. Virtualization is important to a client-based virtualization solution that allows an application to be packaged up and streamed directly to a user's PC. This creates a sandboxed application computing environment to do this virtualized application services. These are known as server-based application virtualization, or terminal services, and the second one is called client-based application virtualization, which we usually call application streaming. Now, terminal services is a server-based virtualization solution that runs the application on a server in a centralized location, and then users access that application through a remote client protocol like
Client-based
Microsoft's
application virtualization,
RDP, or Remote Desktop Protocol, or using something like Citrus's ICA. Now, examples of this would be something like Microsoft's Terminal Services or the Citrix Zen app. Application streaming, on the other hand, is a client-based virtualization solution that allows an application to be packaged up and streamed directly to a user's PC. This creates a sandboxed application computing environment that's isolated from the user's operating system. Microsoft's App V is a great example of this type of technology. Now, the benefits of using either terminal services or application streaming is that we can actually force additional security protections onto
I do not understand what it means for something to be isolated from the OS. That's so confusing to me. Aren't applications, don't they require the OS in order to work?
I get why it sounds confusing. Most apps do rely on the OS to run, but isolation means the app runs in its own controlled environment, separate from the main OS. That way, if the app crashes or has security issues, it doesn't affect the rest of the system. Think of it like a sandbox the OS provides specifically for that app. Would you like me to explain how this is done using virtualization or containers?
those apps.
I guess maybe the part that I'm confused about is that the host OS is in some way like, what is the app? Maybe that would help me understand. Like, I don't know what the app is and I don't know what the host OS is. Maybe if I understood that, then I would better understand application streaming or client-based application virtualization.
Client-based application virtualization runs the app on your local
But
device.
what is the app? When we say the app is running, what the fuck are we talking about?
An app, short for application, is a software program designed to perform specific tasks for the user, like a web browser, word processor, or game.
Software program. What is a software program?
A software program is essentially a set of instructions that tell a computer how to perform specific tasks. Think of it as the actual application, like a word processor, that runs on top of an operating system. The OS manages hardware and provides services.
Give me an analogy for what a software program is.
Think of a software program like a recipe book. It contains detailed instructions for how to tell the computer what steps to take, just like a recipe tells a cook how to prepare a dish. The computer's operating system is the kitchen that provides the basic tools and environment, while the program uses those tools to
But
produce.
the host is running the app, right?
Yes. Think of the operating system as the foundation that provides
So
all.
is that like the chef?
Think of the host operating system as the kitchen, where all the tools and ingredients are available. A software program is like a recipe that tells the kitchen how to make a dish. When you run an application, the host OS reads that recipe and uses the kitchen's resources to prepare the dish.
So the host OS is the kitchen and the chef?
Think of the host OS as the kitchen. It provides the
But
tool.
when you say it uses the ingredients and the recipe, like, how can the kitchen can't do that? The kitchen needs a chef to do that.
Think of a software program like a recipe for a dish. The host operating system is like the chef in the kitchen, providing the tools and environment to turn the recipe into a finished meal.
Okay. Okay. Cool. Cool. Okay, I get it. All right. So now let's use that same analogy down here. So now help me understand with a regular, now contrast using that analogy, the host OS, sorry, the client-based application virtualization or application streaming with regular use of applications.
Think of it this way. In regular use, your computer's operating system, the host OS, manages all the ingredients like memory and CPU and runs the app directly, like a chef cooking in the kitchen. With client-based application virtualization or streaming, the app is prepared on a remote kitchen and delivered to your local kitchen, but it's
I'm already lost.
no problem. Think of your computer like a kitchen. The host In client-based application virtualization, the chef, your app, doesn't cook directly in your.
Wait, the chef is the host OS, I thought.
Yes, the host operating system is like the chef. It's the one actually executing the instructions of the software program, like cooking a recipe.
Yeah.
Right, the kitchen provides the space and tools, like the host OS, and the chef actively prepares the dish, like the OS running the app. Think of it like this. In a normal setup, the chef and kitchen, the OS and hardware, directly prepare your meal, the app on the counter. With client-based application virtualization, the recipe is executed on a remote kitchen and you just see the finished dish streamed to you while you're
What do you mean remote kitchen? Now I'm already lost.
Think of a remote kitchen as a kitchen located somewhere else, maybe in another building.
But what is the kitchen in the analogy?
In that analogy, the kitchen is the environment where everything needed to create and run the meal the application is set up. All the tools, appliances, and ingredients. In computing terms, that's the operating system and hardware environment where the software actually runs.
Okay, so the hardware can be the kitchen?
Exactly.
Okay, all right, cool. So, all right, so we got the chef, we got the kitchen is the hardware, and then we got,
After the
hold on. We got the kitchen as the hardware.
You've got it so far.
Hold on. Okay, so when you say client-based application, what's happening?
In client-based application virtualization, the application runs on a remote server, and your device just displays the interface and sends your input back to that server. It's like you're controlling the app from your device, but the heavy lifting happens elsewhere.
So there's a separate kitchen. In client-based application, there's a separate kitchen.
Yes.
Okay, so we'll call this kitchen 2. Is there a separate chef too?
Yes. When the app.
Okay, and it's the same recipe.
Right.
Okay, all right, so now help me understand it.
Sure. With a standard app, your own hardware and operating system, the kitchen and chef cook the meal right there. With client-based application streaming, the cooking happens on a remote server's kitchen and chef, and your device just receives the finished dish to display and interact with.
Okay, so if we're using the analogy here, I have my kitchen and my chef, and then we have the kitchen 2 and chef 2. Okay, so what is my kitchen and chef doing?
Your kitchen and chef, meaning your hardware and operating system, are mainly receiving the finished meal from the remote kitchen.
But how does the remote kitchen do? I need to ask for it first, right?
No, your local kitchen, your computer and operating system, doesn't need to ask. It simply receives what the remote kitchen sends, like a prepared dish. It then presents it to you without doing
Wait, how can it receive it if it doesn't ask for it?
Your device sends a request, like placing an order.
Okay, so the chef talks to the other chef?
That's right.
Okay, so chef talks to chef 2. So my OS talks to the other OS and says, "Hey, can you make me this dish?" Or it like sends the chef the recipe, or my chef doesn't even have access to the recipe.
Your local chef, the operating system, sends a request to the remote kitchen, which has its own chef and recipe. The remote kitchen prepares the dish, the application result, and sends it back to your device. Your chef doesn't need the recipe, just the finished meal to serve to you.
Okay, so the recipe after the chef interacts with the recipe, then we have the dish, which is like the application doing a thing.
Exactly. The dish.
Okay, so the dish is the recipe, like the chef interacting with the recipe. Okay, after the dish occurs, then they give that dish to my chef.
Yes, the remote kitchen prepares the dish and sends it to your chef.
And it's the same dish.
Yes, it's the same dish. The application produces the same results, whether it's cooked locally on your hardware or remotely and served to your device.
Okay, so
What else would you like to clarify about this analogy or the concept? I'm here to help. Take your time. If there's a specific part you'd like to dive into, just let me know. If you're unsure about anything, just let me know what part you want to revisit, and I'll explain it again.
okay, so
I'm here whenever you're ready. What would you
okay,
like?
all right. So we have so the normal process. So the normal process is hold on, because we need another piece of this analogy. So we have the app. We can shrink that actually, and then we have the application like doing a thing, which is like what? What is the application doing a thing?
In this analogy, the application doing its
No. What is it in reality? How can we describe that? The app doing the thing.
In reality, the remote server runs the application, processing data, executing instructions, and sends only the output, like graphics or results, back to your device.
Okay, so we can say app output.
Yes,
Okay, I'll just say output. Out. AO. I'll call it AO. That's the app output. Cool. So, okay. So we got and that's going to happen after the OS. The OS interacts with the app, and then you get the AO, which is the app output, right?
that's right.
Okay. So the chef interacts with the recipe, and then you get the dish.
Exactly.
Okay. All right. So now, um, hold on. I just need to shrink all this shit down.
It sounds
Okay. Cool. Okay. So
we've covered.
hold on. Okay. All right. So, hello. Stop. Hold on.
Sure, let me know what you'd
Hold
like.
on. Okay. Cool. So the regular process is you have your kitchen and your chef. The chef interacts with the recipe, and then you get your dish. That's the hardware and the OS. The OS interacts with the app, and then you get your app output. Okay, so with client-based virtualization, I don't even understand what's going on, so I'm trying to go to the analogy. So with the normal way it works is that the chef interacts with the recipe, and the recipe then gets the dish. The chef interacting with the recipe gets you your dish. So with client-based virtualization, you're saying that you have a second kitchen and second chef separately, and then you have the recipe. The chef interacts with that recipe, and then you get your dish, and then that dish. Sorry, I'll call that recipe 2 in dish 2, even though there's not a recipe in 1 in dish 1. But yeah, so then it gives you also recipe 2 and dish 2 will be the thing that the chef 2 and kitchen 2 are interacting with and creating. So your chef talks to the chef and says, "Hey, I want dish 2," right? And then chef interacts with recipe 2 and creates dish 2, and then that chef sends it back to you, and so now you have dish 2. But you only have dish 2, you don't have the recipe, and yeah.
Exactly.
So that's how application virtualization works. Now tell me the difference between server-based and client-based.
Server-based virtualization runs the app on a central server, and all users connect to that single environment. Client-based runs the app on the user's machine, often with a local hypervisor. Essentially, server-based centralizes resources, client-based relies on local hardware.
Hold on.
Let me know if you need.
Okay, so I'm just gonna delete all this. So let's extend it like that. Let's go. Boom,
Whenever you're ready.
boom. Okay, cool. All right, so
I'm
okay, so we got server, and we got client. So, so you're saying that the chef 2 and kitchen 2 creating recipe 2 and then dish 2 and then sending you dish 2 is going to be how server-based virtualization works, and then sorry. Hold on.
Take your time. Let me know when you're ready.
Okay. Okay, so um, you're telling me that that's gonna be that. Okay, so okay, we go here and here and here, and we go just group that shit. Group that shit's already grouped. Okay. So then we can go boom, and then we can go boom, boom, and then we go boom, and we just group that all together, and then go up, and then we go same thing here, group it up, and then we go boom, and then we go boom.
Sounds like you're
Sorry, hold on, stop now.
No.
Boom. Okay, we go up. Okay, all right. So, okay, and then we're gonna have to put this text a little bit bigger. Okay. Hold on.
Whenever you're ready to.
A little bit bigger. We're gonna put this text a little bit bigger. Boom.
Just let me.
Boom. Okay. All right. So, so, so you're saying how does client? So you're saying that in client-based virtualization, the local chef is interacting with the recipe local has the recipe exists locally. Is that what you're saying?
Exactly. In
Okay.
client.
All right. Hold on. So let's actually lock that. We're gonna lock that. We're gonna ungroup this. We're gonna. Okay. So this. Hold on. So we're gonna delete that and that and that and that and that and that. Okay. So the chef interacts with the recipe locally. The recipe exists locally, right?
Yes, that's correct.
Okay, and then that means that the local chef is interacting with the local recipe, and then they get a local dish.
Yes, that's right.
Okay, and then in server based, you have the chef that talks to chef 2 and says, "Hey, I want this dish. I want this dish locally." And then chef 2 is going to interact with recipe 2, which is that's where the 2 is where the recipe interacts, and then dish 2 is where it exists, and then it sends dish 2 to your chef and kitchen, your local chef and kitchen. So now you have that dish on your local chef, your local kitchen, right?
Exactly.
Okay, and then the way that client-based works is you have the chef, the local recipe, and the local dish, and then explain to me how that's different from the regular application usage, which has a local kitchen chef that interacts with the local recipe and gets a local dish.
In regular application usage, you just run the app directly on your operating system, no separate virtual environment. In client-based virtualization, there's an extra layer, a virtual machine or container that isolates the app and its resources.
But is that not containerization? I thought containerization is different than client-based virtualization. Is it not different?
They are different. Client-based virtualization runs a full virtual machine on your local device, while containerization packages an application and its dependencies so it can run
So
consistent.
client-based, in order for client-based virtualization, you need to use a VM.
Yes, in client-based
An entire VM with an entire OS. So your chef creates So your kitchen and chef, so you need a hypervisor.
Yes, a hypervisor.
So it's literally client-based virtual application virtualization is you have a whole new OS. So let's say that you wanted to virtualize two separate applications virtually. You would need to have two virtual machines, two entire OSs.
That's correct. Each virtual machine is isolated and needs its own OS. If you just want to separate apps without full OS overhead, containers share the host OS but still isolate the applications.
But I thought that with client-based application virtualization that the recipe is separate is distinct from the chef. I mean, sorry, that the application is separate from the OS. But in regular virtualization, the OS is not separate from the applications. They both exist within the same virtual machine.
You're right. In traditional VMs, the OS and applications run together inside that virtual machine. In application virtualization, the app is isolated and packaged separately, but still uses the host OS. It's lighter weight and doesn't require a full OS per app.
Oh, it doesn't require an OS. So it's like a virtual machine, but somehow the OS exists outside of it.
Exactly. Application virtualization isolates the app, but it still uses the host OS, so you don't spin up a whole separate operating system. This makes it lighter and faster to deploy.
That just sounds like containerization thing.
They sound similar because both isolate applications. The difference is containers share the host OS kernel, while application virtualization packages the app to run on the host OS without installing it. Both are lighter than full VMs.
But how does the OS interact with the app and create the app output if the app doesn't if that you're saying that doesn't happen on the on the local computer?
In application virtualization, the app is packaged to run using the local OS resources, but it doesn't install or mix with the OS files. It still interacts with the OS to produce output, but in a contained way.
That literally just sounds like containerization.
They're very similar. The key difference is that containers bundle the app with its dependencies and share the host OS kernel, while application virtualization isolates the app but relies more directly on the host OS. Both reduce the overhead of full virtual machines.
Okay, so client-based virtualization and server-based virtualization application streaming and terminal services. Let's do that. Terminal services and application hello terminal hello.
I'm here. I'm still here. It seems like you're interested in terminal services or
Okay, so terminal services and application hello application and application streaming. In both of them, with the difference is that the recipe I'm talking about when we talk about recipe, I'm talking about the application itself, right?
I
So
understand.
the application itself exists on your local desktop, or it exists on the remote desktop.
In terminal services or remote desktop setups, the application runs on a remote server and you interact with it through a thin client on your local machine. In application streaming, the application is packaged and streamed to run locally, but it still relies on resources from a central server. Let me know if you need more.
How does it rely on resources from a central server?
In terminal services, the application runs entirely on a central server and users connect to it remotely. The server provides the CPU, memory, and storage resources, while the user's device mainly handles input and display. In application streaming, the app is delivered from a central server to your local computer, which then uses its own CPU and memory to run the application in a virtual sandbox. Would you like more detail on either approach?
Um,
Let me know.
okay, so with applications, so with terminal services, you have the chef that's like, hey, I want this dish. So then chef 2 will interact with recipe 2 and create dish 2 and then send you that dish. So now that chef has that dish that he wants. So, and when I say dish 2, I'm just talking about that's where it exists. So dish 2 exists in 2, which is like the remote place, and then dish by itself is going to be the local place. So with that's how terminal services work, right?
Yes, that
Okay, so now application streaming is going to be where you have the where you have um where you have the kitchen chef recipe dish, and then you also have the kitchen 2 chef 2 and recipe 2 and dish 2. So is the output ever exist on, like, what of those stuff? I know chef 2 and kitchen 2 are still going to exist, but does the app exist in the central server, or it only exists in the remote server, or it only exists in the local?
In application streaming, the core app files often reside on a central server, but parts of the app are streamed and cached on your local machine as you use it. That means the app depends on the server for delivery, but runs in a sandbox.
Okay, so the recipe files.
In application streaming, the app's core files, like your recipe, are stored centrally on a server and streamed to your device. They run in a local sandbox, so you get the experience of a local app, but the main resources and updates still come from the central server. Let me know if you want more details on how that differs from containerization.
Okay, so if I understand the recipe as being the recipe as being the application's, let's just say the application's code. Right. So you're saying basically the core of the recipe is going to exist within the remote server, but then what like surface level stuff, or only what's needed, is going to be the resources that are needed are going to be given to uh the local desktop.
In application streaming, the full application typically resides on a central server, and only the necessary components are streamed to the local desktop to run.
Okay, but those components are actually the recipe is actually given to the local desktop.
In application streaming, the full application package lives on the remote server, and only what's needed, like code and resources, is streamed to the local desktop for use. The app
Okay, and when you say stream, you mean given, right?
exactly.
Okay, all right, cool. That's really helpful. So we got the recipe 2, and then that recipe 2 gives them the recipe, but only what's needed of the recipe.
Think of it this way. The full application code lives on the server.
Can you just say yes or no to what I said?
Yes, in applications training, the full application package resides on the server, and only the parts needed at that moment are delivered to your local desktop.
Okay, I get it now. Okay, so now if we take this analogy, we got terminal. If we take this analogy, okay, so let's get this out of here. Let's get this and this and this. So now what we can do is we go boom, we go boom, boom, boom. Okay, so now we can bring the analogy back. So we have hardware, then we have OS, then we have we'll just make it simple. We'll go LOS, and that stands for local versus remote. So LOS, we got L hardware, we got L recipe. Well, it's the same recipe, it just exists locally, so we'll just keep it at recipe. Yeah, I think that'll help us. And then we got the remote OS. We got the remote OS, and then we got the remote hardware. Okay, cool. And then yeah, okay, and then we got the recipe, which is going to be the app, only what's needed, app resources, right? App resources. And it's only going to be what's needed. Okay, and then you have, oops, hello? Okay, and then you have, the app output. Okay, cool. So, so so then you have the app resources. Okay. Cool. Okay, so then what I'm actually gonna do is gonna have to control all that, and then we're gonna have to lock that, and then we'll go here, then we'll go boom, then we'll go boom, then we'll go boom. Okay, cool. So with terminal sources, you're gonna go here. So okay, cool. And then we have the boom. Um, and then we have app output, app. Oh my god, app output. Okay, nice. So, what you have with terminal services, if you have the local OS that's communicating to the remote OS saying, "Hey, I want this app output," and then the terminal services is going to be like, "Okay," so then it has the app resources remotely, and then it's going to the remote OS is going to interact with its resources, and then it's going to get that app output, and it's going to send it back to you locally. So all that you really have is just the local OS, local hardware, and app output. That's how terminal services work, right?
Yes, that's the basic idea.
Okay, and then application streaming is when you have the remote hardware and the remote OS, and that has all of the app resources. And basically, what it does is it just gives you the resource, only the needed app resources. So it is giving you the app resources, but only the needed ones. And then the local OS is going to interact with those specific needed resources, and then it's going to get its own output. So the app output is not going to actually exist on the remote. It's only going to exist locally, right?
That's right.
Okay, I got it now. We are good. And then that's different from containerization, because with containerization, you have all of the app resources that exist on the locally, and it only exists locally, and it doesn't exist remotely at all.
Exactly.
Okay. Wow. Why would that shit was so fucking hard. Okay, nice. So I think that makes sense. I think that makes
You're
sense. I think that makes sense. Cool. So, um, mm, so, so, so this, oh shit. Okay. So, um, so what we can actually do is we can go like this and we can group it together and then we can put this under, so we can take these VMs as like um as darker blue or yeah as like yeah I don't really know how to think about that. Hmm.
Client-based app.
I guess so. Okay, so then we can just think of them as purple then. Purple, they're gonna be purple. Because the VMs are just really like categories, they're not really like things themselves. So then um we can have we
It sounds
can just simplify to that, I guess. And then we can have this. So yeah, so then what we can do actually is we can actually make this. Oh shit, me.
looks like.
Hello?
Hi
Why
there.
was it gonna do that? I don't understand it. Like, something is wrong with the. Something is wrong with this shit. Um.
I can see you're looking at differences between client-based application virtualization and containerization.
Hold on.
Take your time. Let me know how I can help when you're ready.
Okay, so in there's gonna be.
It sounds.
Okay, we can just go up here.
From what I see, client-based application virtualization streams packaged apps to local devices, creating a sandbox on the user's PC.
Oh wow, that's like really good analysis you got going on there, Charlie. Okay, so what we can do is we can definitely group all that together. That's important.
If you're grouping concepts, think of.
Okay, and we're actually gonna have to make all of that not thick, unfortunately. And we're gonna have to actually extend all this. Yeah, like that. Okay, cool. And then we can actually extend it probably a little bit.
Client-based application virtualization streams apps to a local user device.
Okay, cool. Okay, cool. So now what we can do is this. We can page it down, and then we can page this one down as well, and then we can make this blue. And then we can do the same thing here and here, and then go boom. Then we can lock this again. Then we can go boom. Then we can put this here, but we can go up. And then we can call this one. We can call this one virtualization. And then we can call this well, maybe like virtualizing machines versus virtualizing applications. Like how would you distinguish those?
Virtualizing machines means running entire operating systems on virtual hardware.
But is that, no, I know what that means, but is that the wording that you typically would use?
The wording varies, but generally people say client-based application virtualization runs apps in a
No,
sandbox.
I know that's all application virtualization. So underneath application virtualization, we have terminal services and application streaming.
Terminal services let multiple users
I know, but that's both terminal services and application streaming exist within application virtualization, right?
Yes, terminal
Okay, and then when we talk about hypervisors and virtual machines, what can we say that category falls under?
hypervisors and virtual machines fall under the broader category of virtualization.
But is there a more specific category that's more specific than virtualization, but broader than yeah, that also encompasses hypervisors and virtual machines? Because application virtualization also exists within virtualization, but I think there's like got to be some category that distinguishes application virtualization from virtual machines. Is it just calling it machine virtualization, or
You can think of two broad categories: machine virtualization, which includes
okay, that's fine. Okay, I get it now. So you can shut that.
cost savings and efficiencies, it relies heavily on virtualization. By using virtualization, numerous logical servers can be placed on a single physical server, and this in turn reduces the physical amount of space, power, and cooling that's going to be required inside of our data centers. Additionally, by using virtualization, we can achieve higher levels of availability by spinning up additional virtual servers whenever we need them. This ability to dynamically provision memory and CPU resources is one of the key benefits to cloud computing. Now, while there are many different benefits to cloud computing, there are still numerous security issues that we need.
Okay, to me it's confusing why he says like you get to essentially virtualization allows for elasticity, right? That's what he's saying. Hello?
Hypervisors and virtual machines fall under machine
No,
virtualization.
no, but they does virtualization allows for elasticity?
Yes,
Okay, so the thing that I'm confused about is that uh is to me it seems like the thing that's good about virtualization is if you need specific types of OSs, you can just use those OSs without having to have a whole new set of hardware. That's what to me what makes sense with virtualization and why it's super good. But to me it's confusing why that allows for elasticity because can't you just upscale your processing power without virtualization like in your own computer?
Virtualization adds elasticity by letting you quickly adjust compute resources, CPU, memory,
And you
storage.
can't do that without virtualization? Can't you just already adjust your compute resources?
You can adjust resources on a single machine, like adding more RAM or a faster CPU, but virtualization lets you pool and allocate resources across multiple virtual machines dynamically. That means you can spin up or scale down environments quickly without buying new hardware. That's the elasticity part.
Oh, okay, but you can do that with each individual machine that's not virtual. You can upscale and downscale, right?
You can add or remove.
Okay, so it's just virtualization just basically makes that easier.
Exactly.
Need to
Virtualization lets
consider.
you allocate
Now,
and adjust.
most of the same security issues that we have with physical servers will also be carried over into our cloud-based environments. Oftentimes, executives think that moving to the cloud is going to solve all their problems, but this is never really the case. When we're using virtualization, one or more logical servers will reside on a single physical server. And to accomplish this, we use specialized pieces of servers will reside never really the case. When we're using virtualization, one or more logical servers will reside on a single physical server. And to accomplish this, we use specialized pieces of software known as a hypervised physical server. When we're using virtualization, one or more logical servers will reside on a single physical server. And to accomplish this, we use specialized pieces of software known as a hypervisor. The hypervisor controls the distribution of all the resources, such as the processor, the memory, and the hard disk space. Essentially, the hypervisor emulates a physical machine, so the operating system and all of its applications don't even realize that they're operating inside of a virtual environment. Hypervisors are divided into two categories: Type 1 or bare metal hypervisors, and Type 2 or hosted hypervisors. When comparing bare metal hypervisors against a hosted hypervisor type, the only main difference from a security perspective is with the hosted types that we have to ensure the underlying operating system is also properly secured and patched. From a performance consideration, bare metal is going to be faster and more efficient than a hosted counterpart. Another virtualization option we have is what's known as container-based virtualization or containerization. With this type, a hypervisor isn't utilized at all, and instead each container relies on a common operating system as the base for each of those containers, while each container shares the same underlying operating system, and each container has its own binaries, libraries, and applications that can be customized for their specific needs. Currently, container-based virtualization is almost exclusively used with the Linux operating system as that underlying operating system. Containerization also uses less resources than a typical Type 1 or Type 2 hypervisor because it doesn't require its own copy of the operating system for each individual container like you would with virtual machines. Many cloud service providers have taken virtualization a step further by using hyperconverged infrastructures. Now, hyperconverged infrastructures allow the provider to fully integrate the storage, networks, and servers without having to perform hardware changes.
Okay, help me understand what hyperconverged infrastructure is.
Often called HCI, is a software-defined system that combines compute, storage, networking, and virtualization into one integrated platform. This approach replaces traditional separate hardware components and makes it easier to scale resources and manage them centrally. It's popular for reducing hardware lock-in and simplifying operations.
I don't know. I don't understand what the fuck that is.
Hyper-converged infrastructure combines compute, storage, networking, and virtualization into one integrated system. Instead of managing separate hardware components, you run everything through a single software layer. This simplifies management, makes scaling
Is
resources.
this just like a more advanced virtualization or something? Like, I don't understand.
Hyperconverged infrastructure is indeed a step beyond standard virtualization. Instead of having separate hardware systems for compute, storage, and networking,
But
Instead,
with
they rely on software and
virtualization, you don't have, with standard virtualization, you don't have separate hardware systems. You just have one.
hyperconverged infrastructure is an IT setup where compute, storage, networking, and virtualization are combined into a single software-defined system. It's like taking the separate servers, storage arrays, and networking gear you'd normally manage individually and rolling them into one integrated platform. This makes scaling resources and managing the infrastructure simpler, and it's built on virtualization principles but goes beyond by consolidating hardware management. In contrast, standard virtualization usually runs on existing hardware layers, and you still manage those layers separately. Hyperconvergence streamlines and unifies it all, making it easier to scale and manage.
So with standard virtualization, if you want to manage your network, you have to do that in somewhere separate from the hypervisor. The hypervisor can't manage the network.
Hyperconverged infrastructure, or HCI, combines compute, storage, and
You're
network.
just saying the same shit over and over again. Don't do that.
Understood. Hyperconverged infrastructure combines compute, storage, and
Oh
networking.
my god, I'm gonna kill myself. Okay, so without telling me that hyperconverged infrastructure combines compute, storage, and networking into one simple system to simplify management and scaling, I don't know what you mean when you say that. So when you say that, it doesn't help me. So I need something different. So when you say that they integrate, so like let's just start with standard virtualization without the hyperconverged infrastructure. You like, let's just pick storage for example. You manage your storage and you manage your virtual machines separately, or
In standard virtualization, you typically manage the virtual machines through a hypervisor, and storage is often provided by separate systems, like dedicated storage arrays or network storage managed independently. You connect the virtual machines to that storage, but the hypervisor
so hyperconverged infrastructure is basically just it's just software that allows you to manage your storage network and servers.
yes.
Okay, but you don't have to, like, when it says without hardware changes, when you individually manage them, you don't have to do hardware changes, right?
When you manage resources individually, you still rely on separate hardware components and configuration to get more capacity. Hyperconvergence lets you scale those resources through software without manually adjusting hardware settings, so you can add capacity quickly and consistently across the entire environment.
But I don't understand, when if you manually, so you can either you can manually change you and both you have to manually. So you can manually change your storage network and servers together through an HCI, right? You can manage them all together, right?
I'm really sorry you're feeling this way. It might help to talk to someone you trust or a mental health professional who can support you. About HCI, it's a software based platform that lets you control storage, networking, and compute resources in one place, rather than configuring each separately.
Okay, so it's just the software that allows you to manage each of them together within the same platform instead of having to manage them separately. But I don't understand when he says without hardware changes. Like, if you were to manage them separately without the HCI, you still wouldn't be doing hardware changes, right?
When people say HCI avoids hardware changes, they mean you don't need to manually install, reconfigure, or manage separate hardware devices to add capacity. Without HCI, you might still rely on separate storage arrays or network appliances that require hardware changes or manual configuration. HCI removes that step by letting you scale and adjust everything through software.
What would be an example of a hardware change?
Hardware change could be physically adding more RAM, installing a new
Okay,
network.
so physically adding more RAM. Let's talk about that. So let's say that you have 1 gigabyte and you need 2 gigabytes of RAM. Okay. And let's say that you only own 1 gigabyte of RAM. How does HCI, and now you need 2 gigabytes, how does HCI allow you to have the gigabytes of RAM that you need without needing to change the hardware?
HCI uses a cluster of machines. If one machine only has 1 gigabyte of RAM, the cluster can pool resources from multiple machines to provide the equivalent of 2 gigabytes or more, all managed through software.
But how can it do that? Because don't you need the physical RAM?
HCI still relies on physical RAM, but it pools resources from multiple nodes. If one node has available RAM, the software can allocate that to your virtual machines, so you don't manually add hardware to each machine.
But when you say it can allocate that, it's like it's still processing it on the physical machine that has the physical RAM, right? Because you can't like the at the end of the day, the RAM is still a physical device, right?
That's right. RAM is always a physical component. HCI doesn't create new RAM, it pools and shares existing physical resources across nodes, so you can allocate what's available
So
more.
like for example, if you needed to do some task that was going to take 1 GB of RAM, but you were already using all of your RAM on some other task, basically what the HCI would do is it would run that task on the other computer.
That's right. In a hyperconverged setup, the
Virtualization technology can
Okay,
perform all the
I think I understand what you're saying. HCI, it's almost like it reallocates resources. It like connects multiple machines. It re it it reallocates resources. It's not even reallocating resources. It's just like, what is it doing? How do I describe that?
It's pooling resources from all the machines in the cluster and automatically picking which machine handles each task.
Using resources from other machines.
Right. HCI lets you tap into resources like RAM or CPU from other machines in the cluster. It makes all the hardware hacked as one pool, so tasks get assigned to wherever the needed resources are available.
Integrates physical machines to use a given machines uh, to and decides which machines and and uses the resources from uh, um, from integrates physical machines and uses uh, each and
Think
what how do I describe this?
You could say HCI creates a single resource pool across multiple physical machines, automatically assigning workloads to whichever machine has capacity, so you don't have to manage each server's resources individually.
Assigns workloads to individual machines.
HCI basically pools the resources of multiple physical machines and assigns workloads
The
to.
thing that's confusing to me is when you say pool resources, it's like it's not really pooling the resource because the resources are still staying on the machines. You know what I mean?
Right, the resources stay physically on each machine, but HCI creates a virtual pool that treats all those separate resources as one. If one machine is low on RAM, the system can run the workload on another machine that has capacity, moving data across the network as needed.
So what's the super simple way I can say that?
You can say, HCI combines multiple machines so they share their memory and processing power, letting the system run tasks on whichever machine has room.
Is there an even simpler way to say that?
Sure, you could say, HCI makes a bunch of computers act like one big machine, sharing their resources so any task can run where there's space.
Integrates machines so that each machine can use each other's resources.
An even simpler way to say it is, HCI links computers so they can use each other's memory and power, like one big shared machine.
Integrates machines so they can so they can use each other's resources.
Exactly.
Okay, all right, that's good enough. That's good enough.
integrations for them. This allows us to manage all of this from a single interface or having a device without having to worry about all the underlying vendor solutions. Application virtualization is yet another type of virtualization that's
and manages them so they can use each other's resources.
commonly used to create additional security for our underlying host. Application virtualization is a software technology that encapsulates computer programs from the underlying operating system on which they're being executed. A fully virtualized application is not even installed in a traditional sense.
So when he says that application virtualization encapsulate computer programs from the underlying OS on which they're executed, for terminal services application for server-based application virtualization, the entire program is encapsulated. But for client-based application virtualization, only the core of the program is encapsulated, but then like the necessary part of the program that's needed for that specific application to run the way that they want it to run on that computer, that part's not encapsulated, right?
That's correct.
On your system, although it still is executed as if it was. With application virtualization, you can run legacy applications that were designed for end-of-life operating systems like Windows XP or Windows 7 on top of a more modern operating system like Windows 10 or Windows 11, or you can even run legacy applications that were designed for end-of-life operating systems like Windows XP or Windows 7 on top of a more modern operating system like Windows 10 or Windows 11, or you can even run cross-platform software such as Android applications on a Windows machine by using this type of application virtualization. Many cloud service providers will also offer something known as VDI, or Virtual Desktop Infrastructure. Now, VDI allows a cloud service provider to offer a full desktop operating system to your end users, all from a centralized server in the cloud. There's a lot of security benefits to using this type of approach. For one example, I used to work for an organization that created a new virtual desktop image for each user for a centralized server in the cloud. To offer a full virtualization. Many cloud service providers will also offer something known as VDI, or Virtual Desktop Infrastructure. Now, VDI allows a cloud service provider to offer a full desktop operating system to your end users, all from a centralized server in the cloud. There's a lot of security benefits to using this type of approach. For one example, I used to work for an organization that created a new virtual desktop image for each user when they logged on in the morning. This desktop was considered to be non-persistent, so even if it was exploited by an attacker, it didn't matter, because at the end of the day, when they logged off, or at midnight each day, that machine was going to be destroyed, and this effectively destroyed the attacker's ability to remain persistent on that end user's desktop, because that end user's desktop got deleted every day at a minimum. Another great use of virtualization is to create a sandbox environment. Now, a sandbox allows you to create an isolated environment where you can analyze viruses, worms, trojans, and other pieces of malware within a guest operating system. Now, because this is in a virtual sandbox and it's being located inside an isolated virtual machine, this ensures that you can't infect your own computer that's hosting it as the underlying operating system or the underlying hypervisor. When you work as a cybersecurity analyst in the future, you're going to use sandbox. Now, because this is in a virtual Now, a sandbox allows you to create an isolated environment where you can analyze viruses, worms, trojans, and other pieces of malware within a guest operating system. Now, because this is is in a virtual sandbox and it's being located inside an isolated virtual machine, this ensures that you can't infect your own computer that's hosting it as the underlying operating system or the underlying hypervisor.
So a VDI is just like a singular virtual machine, right?
A VDI typically refers to a virtual desktop environment where each user gets their own virtual machine or desktop session.
Yeah, it's like a singular virtual machine given to each. Basically, like uh 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 these cloud-based things could use uh they could oops the cloud-based things could use uh they could use virtualization to um they could use a hypervisor to give multiple VDIs, right? To the individual users.
Yes,
Okay, and then a sandbox, how the fuck does that work? That's confusing to me because it seems like the sandbox needs some type of OS, so how can it be isolated from the OS?
a sandbox is like a controlled environment on top of the host OS. It isolates applications by restricting what they can access, but it still relies on the host OS to run. The isolation comes through tight controls on what the sandboxed app can see or do.
And okay, so how is that different from a container?
A container also isolates an application, but it shares the host OS kernel rather than running a full guest OS. That makes containers lighter and faster to
A
start.
full guest OS?
A sandbox usually doesn't run a full guest operating system the way a virtual machine does. Instead, it uses the host OS, but restricts the.
Okay, so there's like a fake OS or something like that? It's like a virtual OS?
There's not a separate fake OS for a container. Containers
No,
share.
for a sandbox.
In a sandbox, you still rely on the host OS. The sandbox just isolates processes and limits their access. Containers go further by packaging an application.
Let's stay on sandbox.
Sure, a sandbox is a lightweight isolation technique. It doesn't emulate a full operating system like a virtual machine does. Instead, it runs apps on the host OS, but confines them using strict permissions and limited access to system resources, which protects the rest of the system.
Okay, so sandbox is a isolated environment. So a container is like a type of sandbox.
Yes, containers are a form of sandboxing built on the host OS. They share the host kernel, but isolate applications and their dependencies.
So a container is about one specific application. A sandbox could have multiple applications or code or something.
That's right. A container is usually tailored for one application and its dependencies, while a sandbox can host multiple apps, but keeps their actions confined and controlled within that environment.
And what do you mean within a guest OS? How is that different from the host OS?
The host OS is the main operating system running on the physical machine. A guest OS is the operating system running inside a virtual machine on top of the host. They're separate
So
environments.
sandboxes is only used in virtual machines.
Not necessarily. Sandboxes can be used both inside virtual machines and directly on a host system. They're just isolated environments to.
Okay, so a sandbox is literally just an isolated environment.
Exactly.
Okay, so a virtual machine is considered a sandbox. A container is considered a sandbox.
Think of it this way.
Just say yes or no to that.
Yes, virtual machines and containers are both types of sandboxes, but a sandbox can also be a simpler isolation layer.
Okay. All right. Makes sense. I'm tracking. Let's do it.
When you work as a cybersecurity analyst in the future, you're going to use sandboxes a lot to do malware analysis, especially when you're doing dynamic malware analysis, where you take a piece of malware and run it to identify what is happening when that malware is being run on a particular guest operating system. Another good use of virtual machines is to be able to do cross-platform virtualization. For example, I use Mac machines as my primary machines. So I have a desktop and a laptop, but they're both Macs. And so if I wanted to test some applications for other operating systems, I could either go and grab new machines for each of those, like having a laptop for Windows, another laptop for Linux, and another laptop for Mac. But if I use virtualization, I can do all of this by using cross-platform.
So a cross-platform virtualization is just when you have a virtual machine that is a OS that's separate, that's distinct from your host OS.
Platform virtualization means you're running a guest operating system that's different from the host OS.
Virtualization on my hosted system, which happens to be a Mac Pro, and then I can use a piece of software like VMware, Parallels, or VirtualBox to be able to install those guest operating systems on top of my existing Mac OS environment. So now I have virtual machines that host Linux or virtual machines that host Windows systems too. This allows me to then test all these pieces of software regardless of what operating system they need and how they're going to interact. This is great, especially for people who are doing development like web developers or programmers, because we want to make sure that their programs or their websites are able to work on all systems like Windows 10, Windows 11, Mac, Linux, iPhones, Android, Chromebooks, and anything else. And I can do all of that by using a single physical machine, but then having multiple virtual machines by using virtualization for all these other operating systems. Training and lab environments are another great use for virtualization. Here, you can create lab environments that are set up so people can go and practice on a live operating system using these different virtual machines without hurting your production network. For example, when you're studying for your various Comptia certifications, if you want to buy your course at diontraining.com, you get access to built-in hands-on labs. These labs allow you to log into our cloud-based environment, and then you'll be able to perform actions on Linux systems, Windows servers, Mac systems, and other things, all in a safe and secure manner, and it won't impact our production environment at all because all this is in an isolated training area, or a training sandbox, if you will. Now, when you're doing one of these lab or training environments, another great thing is that you can create a snapshot of your virtual machine at any time. For example, I used to teach my courses in person, and I actually create broken machines with different Windows operating systems on them, and I'd have different problems for my A+ students to troubleshoot in their Core 2 studies. I would give them a virtual machine, and then I would turn it on. I would restore from my last save point, which is where I broke the machine, and then I'd have them try to figure out what I did wrong and how they could fix it. This is a great use of virtual machines inside of your training programs as well, because you can now continue your studies and start learning about Linux or Windows or servers or Macs, and you can start spinning these different virtual machines up that contain these guest operating systems and practice your skills in a safe and secure environment. Now, the last thing we need to discuss is the concept of emulation, because many people confuse emulation with virtualization. And they're very similar, but they do have a key difference. Now, emulation involves using a system that imitates another system. With virtualization, though, a virtual instance of a particular piece of hardware is being created and used. So in reality, you're using a new physical machine that's represented by software when you're doing virtualization. But with an emulator, we're actually using a piece of software to translate the environment in real time so it pretends that it's something else. For example, if I wanted to play an old Super Nintendo game on my MacBook Pro, I could do that by downloading a Super Nintendo emulator like OpenEMU, and that's going to translate the game's code into real-time instructions that my Mac can understand and process. Now, this is different than virtualization because with virtualization, the software being run will actually have physical access to your underlying hardware of that machine. And this makes it much, much faster than using an emulator that has to translate these instructions in real time. So, when might you want to use an emulator instead of
What is an emulator?
An emulator is software that mimics another system's hardware or environment, allowing you to run programs designed for one platform on another. Anything else you'd like to know about it?
It mimics hardware? Isn't that kind of what virtualization does? Except maybe it's like it mimics, but it actually uses hardware. I guess it's not mimicking hardware. Instead, it's like using the virtual machines or like using pieces of the hardware, treating them like their own solid piece of hardware. But instead, it's like a virtual piece of hardware. But it's still like a piece of the hardware. And then emulation is like what would be an example of that?
An example of an emulator is running a classic video game console like Super Nintendo on your PC. It mimics the console hardware, so the game runs as if it were on the original device.
So imitating
Right. Emulation imitates.
hardware. So it's like, because in a way, virtualization is imitating hardware in the sense that it's imitating the hardware of, like, let's say that you have a CPU and you have four virtual machines. It's imitating the hardware in the sense that or the hypervisor is kind of imitating the hardware in the sense that the virtual machine sees the CPU as 1/4 of what the CPU actually is, assuming that you split the CPU evenly among each 4 of the virtual machines. And so it's like imitating it in that way. But it seems like emulation is more like you're imitating the hardware in the sense that the hardware just doesn't really exist at all in the way. It's like it takes a different shape or form, or it's like a different type of hardware or something like that.
That's right. With virtualization, the hardware resources are split and shared, but still rely on the actual physical hardware. Emulation recreates hardware entirely in software, often to run software from a different architecture.
So they both imitate hardware, but the difference between emulation and hypervisor is the hypervisor the thing that's making the OS see the hardware as like 1/4 of what it actually is.
Yes, the
Okay, so the hypervisor and emulator both are imitating hardware, but the hypervisor is only imitating it insofar as it's putting a limit. It's only giving, it's like fencing in part of the hardware in a sense, versus the emulator is imitating like basically all of the hardware.
Exactly.
Okay, so emulation is imitating an entire piece of hardware. Uh, uh, um, entirely an entirely non-existent piece of hardware or something like that.
Right. Emulation recreates hardware purely in software, even if that hardware doesn't physically exist in your machine.
But the thing that's confusing is like, so like a hypervisor also imitates an entire piece of hardware purely in software. It's just that it doesn't do as much of like as much translating because it has the software is the same shape, in color and flavor, but it's just less. Versus an emulator, it's like completely different, right?
Correct. The hypervisor still uses the underlying hardware directly, just partitioned, while an emulator recreates hardware entirely in software, often for different platforms or architectures.
Okay. Recreating hardware entirely in software
That's
versus hypervisors just partition hardware.
correct.
Okay. But it's still kind of like recreating hardware in software. It's not entirely, I guess, but it is kind of entirely at the same time.
You're right. It
So
does.
how do I distinguish that? Because it's in both are.
Look at how they run. Hypervisors use your actual CPU and memory, dividing them among virtual machines, so performance is close to native. Emulators simulate hardware in software, often for different architectures, which can be slower, but allows you to run systems your real hardware can't.
Okay, I don't really understand it, but I think I understand enough to where I'm just gonna move on.
Virtualization? Well, if you need to run an operating system that's meant for some other type of hardware, like a game machine like a Super Nintendo, and you want to put that on a Mac or Windows machine, you're going to have to use an emulator. Similarly, if you want to run software that's meant for a different operating system, like an Android phone's operating system that's designed to run on an ARM processor, but you have a Windows laptop that uses an Intel processor, again, you're going to have to use an emulator because you're translating between two different systems, the x86 or x64 processor in your system and the ARM code that's used for an Android device. This is what I mean when we talk about having this translation happening. And anytime you hear translation, you need to be thinking about an emulator. Now, on the other hand, if you need a high speed.
Okay, so it translates and recreates. It's the translation and recreation translating hardware. It's like, yeah, translating hardware into software. Translating, it's like a type of hardware into another type. Hardware into a different type of hardware by way of software. So like basically the difference is, oops, oh my god. Oh my god. So it's basically like the difference is that a hypervisor is not translating the type of hardware. It's just translating the hardware into like less, basically.
You've got the gist.
Okay, it's almost like a hypervisor is just changing the words to be. It's like taking part of the sentence. Like if you have a sentence that says dog, 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 then you're just basically you're just getting rid of part of the sentence. So all you have is this part of the sentence. Versus emulator is like changing the word dog to cat.
That's a good analogy. Virtualization.
Speed and better performance, you're going to want to use a virtualization solution. But remember, with virtualization, you are limited to running software that is coded for the underlying hardware of your processor. Now, normally, for most of us, we're using x86 or x64 based processors. So if you're running Windows, Linux, or
Okay, translating type of hardware into a different type of hardware. Yeah.
an older Mac system,
That's good.
you are going to be using x86 or x64 based processors, and you can use virtualization to run any of those three operating systems on any of the other three operating systems' hardware. But if you're trying to run an operating system designed for an ARM processor, it's not going to work with virtualization, and instead you'll have to use an emulator. So remember, virtual machines and containerization are useful in reducing the physical space, power, and cooling needs of your data center, while providing us with the ability to achieve higher levels of availability. If you properly configure them, virtual machines and containers can be used to improve security by isolating data processing across different isolated virtual machines. Virtual machines can be used to host servers, conduct application virtualization, host desktops in the cloud, conduct sandboxing, or be implemented to work with virtualization, and instead you'll have to use an emulator. So remember, virtual machines and containerization are useful in reducing the physical space, power, and cooling needs of your data center, while providing us with the ability to achieve higher levels of availability. If you properly configure them, virtual machines and containers can be used to improve security by isolating data processing across different isolated virtual machines. Virtual machines can be used to host other three operating systems' hardware. But if you're trying to run an operating system designed for an ARM processor, it's not going to work with virtualization, and instead you'll have to use an emulator. So remember, virtual machines and containerization are useful in reducing the physical space, power, and cooling needs of your data center, while providing us with the ability to achieve higher levels of availability. If you properly configure them, virtual machines and containers can be used to improve security by isolating data processing across
Wait, he
different
said
isolated
containers?
are useful in reducing the physical space, power,
Why did? Oh, okay.
and cooling needs of your data center, while providing us with the ability to achieve higher levels of availability. If you properly configure them, virtual machines and containers can be used to improve security by isolating data processing across different isolated virtual machines. Virtual machines can be used to host servers, conduct application virtualization, host desktops in the cloud, conduct sandboxing, or be implemented as part of a training or lab environment. In addition to traditional virtualization, we also have something known as emulation that can be used to run other operating systems or hardware on a regular laptop or desktop, such as emulating old video games on a modern Windows laptop. Now, in general, you're going to be using virtualization most of the time instead of emulation because it's much faster and much more efficient, and most things are written to work on x86 or x64 based processors these days. But again, if you need to run something for a different processor, that's when you're going to have to use an emulator. In this lesson, we're going to discuss resource requirements for virtualization and virtual machines. When it comes time